Recording. Okay, recording is started.
अच्छा, चल. So today our guest speaker is the Wardah Inam. She has multiple feather in her cap. First, she is the first Pakistani who did brought a lot of flowers for his herself and for institutions. She is GIK graduate. She did her master doctorate and post doctorate from MIT, and she is the CEO of OverJet. Dr. Wardah is the CEO of OverJet, is the leading provider of the AI solution for the dental industry to help improve the patient care. She has been ranked among 32 most influential people dentistry by uh, Incisal Edge. Prior to the founding OverJet, she led product management at the Silicon Valley based healthcare startup Q Bio work on the biomedical imaging. Before, before that, she was the Post Doctoral Fellow MIT Computer Science and the Artificial Intelligence Lab, where she worked on the remote biomedical sensing using the mechanical learning on the wireless signals. Dr. Inam received a PhD from MIT, where she developed AI powered autonomous microgrid technology. This work received widespread recognition, including the National Geographic covering. It has a breakthrough that could transform the way they power the world. She has also worked on imaging technology at GE Healthcare and Apple. She is the recipient of MIT Graduate Women Excellence Award and the first person in the history of the GIK to receive the GIK University faculty and presidential gold medals. And the another feather in her cap, she's from our PA family and she's the daughter of AVM Inam of 68 GDP. Now,
Uh,
Varda, hand over to you.
Thank you so much for the introduction. And thank you everyone for joining. As Manzoor Saab mentioned, I do have I grew up in an Air Force family, lived in Air Force bases. That meant that I traveled a lot. I stayed in, was in Karachi, Mianwali, Islamabad, and kind of moved along. And I think, a lot of the things that helped me succeed, I kind of base it on that as well. Basically moving in every 2 years and trying to adjust, learn a new system, you start adapting very quickly. And I think, that did lead to a lot of things that I ended up doing afterwards as well. Let me, I have prepared a short, some slides, but I would love for this to be a conversation rather than a presentation. So please do stop me anytime. Let's have a conversation on how AI, first, what is AI? What are we talking about here? And how can we utilize it to help Pakistan, and not only in solving problems, but also in a major contributor to help develop this technology, as I still think it is in the infancy and a lot needs to happen here. So let me just share my slides with you, but please do stop me at any time. Let's make this more of a conversation. Let me know whenever if you guys can see the slides.
Okay.
Okay, perfect. So Manzoor Saab gave a short intro, but a few things and why I'm here is first, I did my undergrad in Pakistan in GIK in electrical engineering, focused on robotics and energy, and then came to the US to do my PhD. Was focused primarily on energy and then converted into healthcare. So we're focused and working in the computer science and artificial intelligence lab, working on new technologies and machine learning and how their applications to help solve major problems that exist. And for that, after that, I basically ended up working at Q Bio, Silicon Valley based startup doing biomedical imaging. And how do you make MRI faster to acquire, cheaper to happen, and better. So and have some other experience at Apple, GE, created my own company in energy infrastructure as well before. So so just to give you an idea of where I'm coming from, and some of the areas that I can talk about, even if it might not be covered in the presentation. So if you have interest in energy, in AI and energy, etc., can help answer those questions too. So just to give you a little bit about OverJet before I start generally talking about AI. So I'm currently running a startup called OverJet, and we at OverJet we're in the dental space. So the idea here is that if you can actually, if machines could understand data similarly to humans, in this case, if they could read dental x-rays, similarly how a dentist would read an x-ray, what could you do with it? And in our case, we can do a lot with it. And we are serving insurance companies. So we're probably the largest provider of automation in the dental insurance space when it comes to clinical review. And that means in the US, if you go to the dentist, your x-rays get taken, and the x-rays that the dentist has taken, they're sent to the insurance company for review to determine whether that a treatment that the dentist is recommending will be paid out or not. That's currently that is all done manually. And with our technology, we're automating that whole process. So you don't need a human dentist looking at the x-ray and saying, yes, it meets medical necessity or not. You can actually have automation at scale, and now you can process millions of x-rays and determine and provide determinations accurately with machines. And I can talk more about this, but I won't focus too much on this particular application here, but I can go into more detail if needed. So what are we talking about here? When we talk about artificial intelligence, we believe that this is the new electricity. Not only has it transformed many industries, but it's going to transform almost every industry that we deal with, whether it's finance, education, agriculture, you name it, any industry that you can think of, AI is going to have a huge impact. So the idea here is not only to see this happen, but how can we be part of the transformation? So, early 17, 18 or 1800s, with the steam engine, things completely changed. Then you had the advent of electricity, the 1800s, 1900s, and we're still reaping the benefits of that. So it doesn't, we saw the industrial revolution with it, but the technologies just don't go away as well. And 1900 were really focused on better computers and computation at the home or personal level. And here, again, computers are still part of our lives. And the next revolution we see here is intelligence. And here, and I'll talk more about, what are the technologies here that are of interest. But this is going to be, for at least the next few decades, intelligence is going to be a major part of how the new transformation that happens and how industries transform, and how people live their lives. So it's an important time to be part of this revolution and help shape it. So, now the question is, what really is AI? We hear a lot of these buzzwords around. Simply put, artificial intelligence is intelligence demonstrated by machines. And artificial intelligence currently is all around us, although there is this potential of what's going to happen in the future. But even currently, if you're using Netflix, the recommendations you're getting, whether it's for your favorite program or it's saying, because you've watched a particular episode, you should be watching this particular episode, that is AI. If you're using Facebook and your image is getting photo tagged itself, that is also AI, a specific kind of AI, which is computer vision, but a kind of AI. Google giving you recommendations on when you're searching and it's saying, giving you the next recommendation, that's also artificial intelligence. If you're using Apple products, have the Apple Watch, it's also looking at your data and making sense of the data using artificial intelligence products. So just to kind of point here that although we have this huge transformation that's going to happen, but AI is already around us. and it's improving every day. So what what are the terms that we should know of right now? So you might have heard of artificial intelligence, machine learning, deep learning, supervised learning, unsupervised learning. So there's some terminologies that people throw around. But the idea here is the same, which I started off with. The bigger bucket here is intelligence demonstrated by machines. So the same way that humans think, can machines start to replicate it? We're still in very infancy of this. However, the applications are great even now. But I would still say, like, for machines to be demonstrating intelligence, we're literally in the infancy. However, it does have a lot of potential because machines don't sleep. They can run forever. They don't get tired, etc. So they can add a lot of value as well. So if you take the bigger bucket, which is artificial intelligence, so it would be the most common buzzword. So in media, you will hear this buzzword used a lot because it encapsulates everything else that I talked about, which is machine learning, deep learning, supervised learning, natural language processing, and other terminologies. So if you want to talk about any of these technologies, you can confidently use the word artificial intelligence, and that should describe any of these technologies. Then there's a subset of artificial intelligence, which is machine learning. And machine learning is what has gotten a lot of attention recently. So artificial intelligence has existed since the 50s. Machine learning, and particularly deep learning, which is a subset of machine learning, has gotten attention since, I would say, 2010, 2012. And so this is pretty much very recent technologies that have developed, and that's why there's so much potential currently as well to be part of it. So as we talk about machine learning, we're talking about algorithms that can get better as they see more data. And as you can imagine, why this is so important right now is because we have so much access of data and excess of data as well. And then you have a branch inside of machine learning, a special branch called deep learning. And in deep learning, we're talking about specific models which are deep. That means they have a lot of nodes and a lot of layers connected. And just to give you an idea, what am I talking about when I talk about nodes? If you think about the human brain, a human brain has billions of neurons connected together to give you your cognitive abilities. And what scientists have tried to do is they've tried to mimic what's happening in the brain, or take inspiration from what's happening in the brain. Of course, we cannot replicate that. So we're taking inspiration from what's happening in the brain and creating computational models, which have millions of neurons, or in this case, millions of nodes connected together to give or encode human understanding into these models. And I can talk a little bit more about that, but the basic idea is why these models are doing well is because now you have very large models, again, millions of nodes that you can connect together and train them to learn the same way that a brain would learn, and start providing outputs and start recognizing patterns, or start doing simple tasks. I would stop here. Are there any questions?
Dr. Wardah, I have one question, please. Can I ask?
Please.
You were talking about the deep learning, and mostly the neural network model is used. But I've heard that this model, the way we model the brain, is not really the neural networks. They are thinking, they are probably, close to that. All the neurons are fired and all that, but that's not the real, brain that works, because even in the Sweden, they have supercomputers and they are not able to model the human brain.
Yeah,
which
absolutely.
is still, in the modeling phase. But probably this deep learning or neural network is a little, you can say, one way of assigning weightages and everything and trying to learn.
So that's why I use the word in inspiration or mimicking. So we're not actually, it's taking inspiration from the brain. So the inspiration, and it's nothing more than the fact that the inspiration is that in a brain, you have neurons connected together to give cognitive abilities. In these deep learning models or neural networks, you have nodes connected together to give you machine learning abilities. So it's literally, the concept has taken inspiration from the brain. It isn't replicating the brain in any way. So that's why also mentioning the fact that we are really in the infancy here. Although the application itself, there are a lot of applications, but you can see how beneficial this technology could be. Even though we are so much in the infancy, we can still provide so much value with using the technology. So as you can imagine, as we get better with these models, where we start replicating more of the brain or get closer to the brain, you will see even better or much wider applications, but we're not even close to that. What we're good at right now is what is called narrow intelligence, which is solving very specific tasks. What we're not good at is general intelligence, which a human brain has. For example, while you're listening to me, you probably are, understanding what I'm saying. You're listening to my voice. You're also watching this presentation. There's something going around in your house as well. There's some car going outside. You're listening to that as well. So you're actually doing a lot of things at the same time and are able to deduce different aspects. You're thinking out whether I should ask a question or not. There's a lot happening in your brain. We're definitely not close to that. What we're able to do right now is have very narrow intelligence. Basically, if a machine learning model was looking at this presentation, it might be able to say, hey, probably this presentation is about artificial intelligence, but that's about it. It's not, or it's listening to my voice and trying to understand what I'm saying and turning into a text. It's not able to do all the things that we as humans can do right now. So it's a very good point. Thank you for bringing it up.
Thank you for the detailed answer. Thank you.
So the other aspect and why I'll get into supervised learning is, and to actually stress on why why we're not there, in the sense that why we don't have general intelligence, why we're very, very limited, is because the technology right now that is really, really working is supervised learning. And supervised learning is a subset of deep learning. There's supervised learning, there's semi-supervised learning, or unsupervised learning. And unsupervised learning is where we want to get to, which is without given an input, can the machine learn itself? But right now, we're kind of all the advantages that you're seeing, or the applications that you're seeing right now, I won't say all of them, but most of them are focused on supervised learning. And we're in supervised learning, what we're doing is we're giving examples to a machine with labels. So in this case, say we give this example, say, the same way that you would try to teach a kid, you'd say, hey, what do you see? A cat, right? You show the cat a few times and the kid would be able to learn. Now, probably for a kid, you don't need to show them a cat image like, that many times. And even if the cat is on a tree, or it's on the couch, or it's upside down, a kid might be able to tell it's still a cat. That's a difficult problem for a machine. So because of that, we have to give the machine a lot of examples. And when I say a lot, to get really, really good, we're talking about hundreds of thousands or millions of examples. Because for a machine, again, we are much smarter in a way, or even a kid is much smarter, where once they get the concept of a cat, whether the cat is, and whether they had seen a black cat, if they see a white cat, they can still tell it's a cat. But for a machine, we have to give it examples and teach the cat that this is a cat. So that means it still requires a lot of human input. And I'll get to why I'm bringing this up when we talk about what all can be done in Pakistan. Is one of the things is this human input is very time consuming, costly, etc. How do you actually utilize different skilled and non-skilled resources to help input these labels into machine learning models? And second would be, once the machine has learned, now it knows what's a cat. Now, if you give it a cat and dog images, it'll be able to say, okay, no, this is a cat, this is a dog. And the same concept can be applied to any other application. So for example, if we start saying, okay, this is a tumor, and this is not a tumor. This is a tumor, this is not a tumor. Very quickly, the machine can learn what is a tumor and start able to, without input, start able to replicate that output. So whether you're talking about healthcare, whether you're talking about just self-driving cars, or you're talking about other fields, the concepts remain the same. The simple thing of cat, no cat can be replicated in different ways. That particularly is called detection, where you're just detecting what it is. Then there are other techniques. If there's interest, I can talk more about it later, of what are the other techniques that are utilized. So the two major applications right now that are getting all the attention, one is computer vision, the cat example I gave, and that is what machines are good at. They're good at pattern recognition. So once I give it, hundreds of thousands of examples or millions of examples, okay, this is a car, this is a truck, this is a person, it can start learning what these are. So that's the computer vision side of it. And there's going to be a lot happening. Anytime you're making a decision based on visual information, that's where machines are going to come in. So you can see other applications, probably nobody has touched them right now, but they might be ready to be disrupted if you're using visual input into the problem. And second is NLP, or natural language processing, and that itself used to be a very tough task. And even now you might say, my Siri doesn't understand anything I say, but the technology is getting much better. And especially when you talk about understanding text, you've had for a long time object character recognition, or OCR, taking handwritten notes and converting them to digital notes. And those technologies are just getting better and better as well. So being able to take voice as an input and be able to do something with it, those are other technologies. And just to kind of give you a little understanding of why was this not possible before, and what are we really enabling here. So if you think of if you think of computer systems, a lot of it relies on storing the data, processing that data. So if you wanted to query, say, if you had a financial file, so think of an Excel sheet. You had an Excel sheet and you wanted to say, okay, will I, what does my financials look like? Will I make a profit? You were able to easily write formulas, query those. However, and that's, the technology used that was structured data. So data that could be fit into a database and you could query it. The issue with images and or voice was that you couldn't just query an image. You couldn't say, before the advent of these technologies, you couldn't say, give me all images with a car. And now with the advent of these technologies, now you can say, okay, I've identified car. Let me put this into this unstructured data into a structured format, so I can help query it and determine, how many cars are there on the road? How many, if you're looking at satellite images, how many houses are there? So you can start actually making sense of the data, and the data doesn't need to reside in just an unstructured data format. It can be provided in a structured data format. And these tasks, you needed humans to do them because machines couldn't really process that information. You needed humans to process that information. And now with machines being able to process that information, you can now do it at scale. So you can look at it, say, satellite images of the whole world and say, okay, how many houses are there? How, which houses don't have a road? How much greenery is there? And start processing information at scale. Are there any questions on this?
Not now. What is the basic difference between the NLP and the computer vision algorithms?
So underlyingly, I wouldn't say there's fundamentally a big difference. It's just the techniques are different. So you would be building it in the same way, the models. Here, first step would be training the data. or training the models or annotating the data, where you're taking input, whether it's a voice input, whether it's text somebody has written, say an essay, and you're identifying findings in it, and that is a human input is required. So if you had an image, you will be saying, okay, in this case, you'll be saying, okay, where's the truck, where's the person, etc. And you're using human input, so annotation phase. In natural language processing, say it's an essay and you want to start understanding legal contracts. You will be identifying words or sentiment in that and using human input to say, this is a noun, this is, here, this is the subject, this is the actual conclusion. And after you, then you input, hundreds of thousands of those data points, the models start to learn. And then when you provide it an input, which it has never seen before, so an image without any input or a legal contract, it can make sense of that contract. So the techniques differ, however, the approach remains the same. So, for example, even in our company, we do computer vision and NLP as well. Same people can actually work on both. But of course, there are experts in NLP and then there are experts in computer vision, but the techniques, a lot of the fundamentals remain the same. You would use different techniques because, of course, on an image, it's a 2x2 that you're looking at. In a text, it's more of like a vector that you might be analyzing.
Okay, can NLP, let's say, scan a document and it can give marks? Like paper checking is one of the difficult things. So can it do automatically?
Yeah, so that's a good question. I think anybody has actually done it, but that's a very good application that might be something that somebody could actually work on. Is one is just, is the answer correct or not, or that would be the easiest bit. If it's say a mathematical question, did you come to the right answer? Did you use the right approaches? But also more sophisticatedly, if you wrote an essay, how well was it? But I'm not till now seen an application here, but that's some place that I think definitely NLP could be very helpful.
Okay, I think where yes or no answer is there could be possibility, but if somebody has to elaborate in different way, it would be difficult.
No, so if you look at what's happening right now in NLP, it's fascinating. So I would recommend you guys checking out GPT-3. So GPT-3 is a technology being developed by OpenAI, this company, and you would be surprised. What they've done is they've taken all internet's information, and now if you say to it, write me an essay of how AI can help Pakistan, it probably does a better job than I'm doing right now, and can literally write you an essay. Of course, over time it'll only get better. But from GPT-2 to GPT-3, we've seen ridiculous improvement, and right now it's the amount of input that has been added, and the beauty of it is because you can take all this text that is existed on the internet, you can it can learn through hundreds of billions of essays, hundreds of billions of like really good input as well. So I would definitely encourage, if somebody's interested in like where we headed, it's pretty frightening and surprising to see how good with these like basic technologies we've been able to get so far.
I've seen it's a real life example of GPT where they deployed a robot somewhere close to a volcano. And when it was erupting, it was live reporting from there. I mean, it was amazing. It was just, I mean, if they didn't tell me that it was some robot, I would have thought, oh, it is somebody who is speaking there. But it was a robot, it was reporting there just in a natural way as any other reporter will do. And the reporter was frightened, oh, my job is at risk now. Was reporting that.
No, absolutely, and I think with with some of these essays, etc., you see, and they even did a paper. So a paper was written about a new topic, and it was very hard for people to, and it got accepted as well. So it's very hard for people to now start telling. So I think with NLP, especially because there is that much data, and you can also do more unsupervised learning compared to images. There's a lot to be done, and I think NLP, I would say, is even more advanced as a field than what we are in computer vision. So definitely really interesting applications. And the good thing is, now that you have all these models that are pretty much, you can get them off the shelf, there's a lot of the application is more important, or is becoming more important. So the application that you guys mentioned, like, I've not heard that before. So that's probably a really good application to start looking at and saying, okay, could we use GPT-3 to start doing X, right? And the actual idea is, taking these models, really refining them for your particular application such that it starts adding value. And similarly to, how you had, when you were like starting to software program, early on, you had to write everything yourself. But very quickly started, there were languages developed, frameworks developed. Now nobody's writing, basic low-level stuff, or or in this case, even writing very basic models. What you're doing is you're using what the frameworks that exist in right now. It would be PyTorch, Keras. And they're coming from companies like Facebook, Google, and you're utilizing really good models and frameworks, of course, changing them for your particular application, but it's a very easy way to get started.
Another example, if I may allow to say about natural language processing is, one day I was talking to my Google assistant, right? I was asking something. I don't know. मैंने उर्दू बोलना शुरू की. Just, I don't know what I was doing. I just started speaking Urdu. Can you believe, without any configuration, without any setting changes, started speaking with Urdu? उसने मुझे उर्दू में जवाब देना शुरू कर दिया. And बाद में मुझे काफी देखना पड़ा कि मैं उसको दोबारा सेट कैसे इंग्लिश पे कैसे ले जाके सेट करूं. So this is a very, real life example that they do understand. And that was surprise for me. I thought कि Google Assistant उर्दू नहीं समझता, लेकिन पता चला वो 2018 से उर्दू समझ रहा है. They implement this language there.
It's also because the amount of desis we have in, say, Google is probably, probably a majority. There will be a huge population of desis in these large companies as well. So I think there's an advantage that we have, especially because we're the ones kind of building these technologies, whether it is for these companies or in general. So I think whether it's it probably was closer to Hindi than Urdu, but there's a lot to be done here. And how do you again, what we need to look at is also for countries like Pakistan, etc. How do you utilize these technologies in a better way so that we're not just solving the first world problems to begin with.
Yes.
So just to give you a little sense of what are the current challenges. So say for our company, what do we have to deal with? Number one is there is a huge supply-demand gap of talent. People who know, or were good software engineers who come into AI is very, very less compared to how much demand there is. It's probably the hardest the job to be recruiting for, especially if you talk about NLP or computer vision. People who know this well, and there is literally, I would say, like 10 jobs for every one person in there. So that's, I would say, a huge opportunity for Pakistan, especially with the amount of software engineers we have, and to be creating AI engineers. And here's specifically, even there's a lack of good software engineers who are in AI. It's not just AI engineers in general. A lot of, if you look at the machine learning scientists, etc., they've either come from physics backgrounds, or they've come from electrical backgrounds, or many other, or probably aeronautical engineer, different backgrounds. But being like core software engineers is still less. And I think the people who are core software engineers going into AI have an edge. Because it's not just about developing the models, it's about deploying the models, it's about metrics, it's about so many other aspects of it. And people who don't know the other basics are at a disadvantage in a way, even though they might be the best machine learning scientists, but the the speed with which they can do experiments is reduced. Second that I see as high quality annotations is extremely costly, but also a lot of headache. So for us, we actually have a 60 people team. We have 30 people in the US and 30 people actually in Egypt doing annotations for us. And a few people in Pakistan as well, which are run by the person in Egypt. And here we're paying anywhere from $6 an hour to like $75 an hour to for the annotations in general. That is the human input that's going into training these models. So it is a very costly endeavor, and a lot of the and there's a need for high quality outputs as well. So for example, there are big challenges in if you have say let's take the example of the image of the road that I was showing. If somebody by mistake mislabels a person as a car or a truck as a car, if you do it one time, it should be fine. But if you do it so many more times, the machine just does not know that you've made a mistake. It just starts to get more confused and starts to learn that that might be a car. So the machine is only as good as the input. So it's like, I think it's very commonly said, if you put junk input, you're going to get junk output. So the most important thing, even more important than the models that you're building, is the input that you're providing it. And that's where I think, at least right now, there's a lot of challenge. And the third is computation is very expensive. Even though, these deep learning models have been, have developed so much in the past, 10 years, primarily because of compute becoming much cheaper. However, even now, I would say per machine learning scientist, our budget is about at least 10 to 15,000 per machine learning scientist. So like think, just being spent on their computation that they're doing. So there is this per month. So, and that is even with limitations. If, the computation is still very expensive, but, and there are ways again to help solve that as well. But the first two, I think Pakistan could play a major role in it. One is the supply demand gap. And being able to now train all the software engineers we have into AI engineers. And definitely there is, of course, a salary increase if an AI engineer gets paid much more than a software engineer does, but also the demand is much more higher for, the demand might be the same, the supply is much lower for an AI engineer than a software engineer right now, specifically because you don't have, there are very few schools which have developed pure AI undergrad curriculums, and even those are very limited right now. But there is an opportunity. There is enough information online for for people sitting in, say, even Pakistan, to actually learn the basics, whether it's using Coursera or Stanford's online courses, or there's Udacity. There's so many other sources out there, and there's some which are really good. I would say you need 3 or 4 major courses to start getting really effective in these to start developing these technologies. Second is we have a, especially this is probably, it has hopefully changed since my experience at GIK, and I came to the US in 2010, which is this lack of focus on research and not knowing how to really read and implement papers. How do you assess which paper is good, which paper is not? And I think that's even a more simpler thing to be doing in schools, etc. And probably more, online education needs to be developed around how, it's something that I had to, when I came here, I started understanding on, how do you understand if paper is good? How do you read it in the right way? How do you make sure that you're contributing beyond what is actually developed in the paper? But those are things, the good thing is there are free online sources where right now, the deep learning or the machine learning community is providing a lot of content for free. So archive.org is a great resource for free papers to be accessed and then and built upon than what's happening currently. And lastly, I think that's where we need to kind of focus on as well is mentorship to guide the talent. The difference, say, would be from GIK to MIT would be, I had a professor who could guide me into, what's good, what's not, etc., which saved me probably a lot of time, which if I could, even if I could get to that solution, it might have taken me a very long time. And that, there is recently developed this FATMA fellowship by a few students from Stanford, and they got some other major people involved, some Pakistanis also involved in this process. But the idea here is, can you get Pakistani students to get mentorship from people who are working or experts in these technologies, so that they can actually start building and producing as well. The biggest, I would say the advantage here is software is, very cheap to get started on. You don't need a lot of infrastructure. You need your computer, with a lot of people have, and you can start building and producing basic stuff very quickly. There's free resources such as Google's Colab, where you can start building your models and using their GPUs for free to start getting started. There's other resources that you might get access to as well. But so getting started is much easier, but being really effective and being really good is harder. And that's where we need access to these papers and more mentorship, so that you're not an average engineer, you're actually the most effective engineer. If you can be that more effective engineer, you have all the resources needed to be effective as well. Are there any questions here? I'll stop here. Sorry, I didn't stop for any questions before.
Please continue.
Whosoever interested will ask the question.
Okay, perfect.
You see, the problem is that more than the software engineer and AI people, the decision makers need to be aware of what can be done, what possibly could be done with AI, and which are the domains which need to be prioritized. Because AI is not a silver bullet which will work everywhere. It has to be specific to a task, specific application for a certain job, for a certain purpose or end result. So to put it on the right track in Pakistan as a country, as a nation, the decision makers have to be educated, and they have to understand the complexity of this, or the possibilities or the potential of this, because there is work going on in bits and pieces here and there. There is one is under the president, that there are other setups where it is happening. But what we need to do is to have a building block approach as to how the work in this field needs to be prioritized.
I think that's a very good point. I think it has to go both ways. You need the bottom up, you need enough talent to be useful, and then you need the top down approach of ensuring that we're headed in the right direction as well. And in this case, the good thing is it's lower cost than any hardware solutions, etc., that we've had to deal with in the past. But the hard thing is that how do you ensure that the right problems are being dealt with, the right approaches are being used? But a lot of these things, happen after, there needs to be some trial and error, there needs to be some improvement, and over time, it gets refined. The good thing is this is going to go for the next at least multiple decades, so we have the time to start working on it, improving it, and getting getting better at it. But absolutely agree that there needs to be some top-down leadership as well to ensure that that we're going in the right direction.
Dr. Wardah, taking this discussion and point to a little bit further, what is your take on, let's say there was a big field, about 10 years ago, there was a field called GIS data, right? You go and collect all the data, sunsets data, buildings data, and all the data, and put in a map. It was a humongous task, very costly. What about, can we use AI using, let's say, aerial pictures, satellite picture, or maybe aerial pictures, and then analyzing those pictures and doing, for example, consensus, doing some planning, doing spying maybe on the enemy? Is it possible to use AI in those fields?
No, absolutely. And I think that's where I think where we would have a lot of the advantage as well, where you can start producing a lot of good results with very few resources. And so, for example, if you wanted to start, of course, the good thing is, as you said, there was this, an effort on collecting this GIS data, and you definitely need the data to get started on machine learning models. But now the outputs can get much more effective with machine learning models rather than without them. So, it was all about big data, say 10 years ago. How do we get, the more data was considered better. Now the question is, yes, we have more data, but what do we do with that data? And that's where deep learning and these technologies come in, is making that data more useful. So to your point of, I would say the good thing is, I believe that AI is going to impact every little vertical. So it doesn't, you can start with the major problems and start trying to solve them, and have, even if you had like a 3-people team solving, one of the problems, that's enough to be solving. You need a machine learning scientist and an engineer, and probably somebody managing the effort, and you pretty much you should start getting solutions in, say, 3 months or so. So the speed with which you can actually create value is much faster now. And to your point of like taking that major data set and dividing it probably into smaller problems and saying, okay, let's look at consensus right now. What information can we gather from this data in a way that we can actually scale it up, and we will never probably need to do this again. You can just provide an input and it'll give you the output as well. Yes, the first time it'll take an effort, but after that, once these models are trained, then you start automating these solutions as well. And that is why, over time, if we don't do this right now, over time, we're just going to just be behind all these other countries so badly, because they would have spent time and developing these automated models that now after that, it's a compounding effect. The more data you put in, the more results you're starting to get, and you don't have to redo everything again. So that's at least, one of the things I see. And in trying to get into, where can we really add currently a lot of value is in the development of these models as well, which is, when it comes to annotations. Number one is, high skilled and low skilled annotators. So being able to have annotation, being done as a service. We had these software houses as a service, which did really well and moved and created a lot of software engineers for us and provided them with a lot of jobs. Now we have an opportunity to create annotation houses in a way with high-skilled talent such as dentists, doctors, engineers, or low-skilled annotators, which can identify everyday objects as well. And then second, we have, the bigger challenge here is how do you ensure anybody could, get engineers together, but how do you ensure quality outputs, QA, management? And that is where, again, utilizing what we've done with the software houses, with ensuring the QA, ensuring that these products are actually useful. Similar, annotation houses need to be developed and can employ a lot of people and provide them jobs as well.
How can effectively it would be? Sorry, go ahead, please.
No, please go ahead.
How can it be effectively utilized in the agriculture area? And if it is being used effectively in the reconnaissance area, how safeties could be contributed?
So I think I was getting to the agriculture. I'm giving one example, but there's a company that I know of, if you want to look at, it's called Ricult, RICULT. They're doing some work in agriculture in Pakistan and other areas like Thailand, etc. It's MIT grad as well who went and started the company. So it might be worth looking at that, of how they're utilizing it. They're utilizing it majorly two ways. First is I think Saleh mentioned, looking at the satellite imagery. They're utilizing to determine how the farms, the smaller, the plots that the farmers have, how have they performed based on how much rain you had, etc. And being able to then project what's going to happen and whether they're going to pay off their credit as well. So rather than the farmers relying on loan sharks for credit, can you make credit accessible based on the current resources they have, and using those as a new way of credit scoring. And they're enabling it through satellite imagery and artificial intelligence-based models based on the crop data as well. So there's definitely, in agriculture, there are applications, people are working in Pakistan on it. I believe healthcare is a major opportunity here, where not only can you reduce cost of healthcare, but make sure that you're providing access to good quality care, whether it's diagnosis of radiographs, or it's providing telehealth solutions. All of those are going to come in the healthcare space. And specifically, in dentistry, I know that we have a huge shortage of oral radiologists, which is, there are 1 or 2 Pakistani oral radiologists in the US, etc., but there are literally no oral radiologists in Pakistan. So this is an opportunity to provide, good solutions in a low-cost manner to Pakistani population as well. Here, fintech is another big application, right? How do you, right now, compliance is very hard. Microfinance credit is very costly. Using these technologies to help reduce the cost of compliance, credit scoring. Security is a big one as well, which is utilizing, and that comes under the computer vision domain, where you're utilizing computer vision data to determine image-based surveillance, tracking, and really reducing the cost of this. So, the one thing is, the way you need to think about it, is the solution costly right now? Having more data, would it provide more results? And lastly, do I need to process a lot of data? And if the answer is yes to any of these or all, that means it's a great application for AI. And that is something that you can start thinking about as you start thinking about areas that you want to work on, or you think people should be working on in this space too.
Well, Dr. Wardah,
please go ahead.
Yes, Dr. Wardah, my question is, with the kind of literacy level in our country, there's a lot of informal academia. But, there's no, formally, we're not that academic. Let's put the academics aside. But, there's a lot of informal academia. While we were talking of agriculture, we have, the farmers here who, can, do wonders with the land with their skills. So how do we relate this artificial intelligence with this informal academia? That is very important for our country, even for, because it's a game of data. Now, even if it is data, how best can we utilize this data for these people who are not very literate, but their level of informal academia is very high. So, their neuronic activity is very high. So how do we link this artificial intelligence with this kind of configuration?
Yeah, no, that's a very good question, and I love how you're thinking about this here. At least my 2 cents are the one, or at least even the technology we're developing, we think of them as assistive technologies. They assist the person doing the task with a particular task. So, for example, when I'm talking about a dentist or a doctor or somebody like reading a radiograph, this is assisting them. So when you're talking about a farmer, your skill level is even much lower there, right? So the amount of assistance needed needs to be even smarter. So whether it's about the right information being provided to them at the right time. So, for example, say, if I gave you, if you were managing the farm, you might be able to just go on the internet, figure out everything that you might need. What are the inputs? How do you optimize it? However, somebody with non-formal education might not be able to do that. So, what the role of the technology here would be is providing them the right information at the right time with, and in a very condensed manner. So whether it might be like, this is the right time, X, Y was noticed, this is the right time for you to do X. So insights being provided, I think that might be a very good, earlier ways how we can assist them, and then you seeing their behavior. Does the behavior change with the particular information? You can start producing behavioral based models and determining if this work, what should happen. So you can get more sophisticated later on, but having very actionable insights being provided in bursts of information, I think is the way to go with informal or less formal education.
Dr. Wardah, I have a question for you. You have mentioned that this particular AI field is fast growing all over the world, and many countries are quite advanced in that. And the basis of using AI is dependent upon the data that you utilize and educate or teach the machine to take decisions. This effort may be going on in silos, in compartmentalized format, but is there somewhere universal data bank which all people interested in developing AI applications can use across the board?
So there isn't, and I think that's one of the major challenges as well. And it's also one thing about interesting thing about the data is also it really depends on. So for example, for us, when we work from one insurance company to another insurance company, we're talking about the same population. We're talking about the same. We're still talking about the U.S. Just going from one insurance company to another insurance company, we see the distribution of data change. And this distribution of data changing, it might be one insurance company has more younger population than the other. Small changes can actually change the output of the models. And that is why you won't have one single model which can solve everything. And that gives you an opportunity to start developing more local solutions for your particular problems as well. And in this case, the quality of the data actually matters. The way it has been inputted also matters. The slight distribution changes also matter. The idea here is we're going to get more and more specialized models for particular cases. So if you're talking about, can you take, the model, say, we've developed with US data and apply it directly to Pakistan? You might not be able to. You could do it, but the results will be really bad. And the idea here is that's why, there's a huge opportunity for local entrepreneurs to develop and use the same stuff that you're seeing in different countries and start utilizing the local data to start solving the problems as well. So if you think, rather than as a negative thing, I think there's an opportunity to have more distributed development of these technologies happening and more localized problem solving happening, which will help more people than having a monopolistic company providing solution for everyone.
Dr. Wardah, it's a very informative presentation from you. But you've only discussed about the upside of the technology AI, but there definitely there are downsides also there. For example, we all know there is a struggle going on between China and the United States as to who is going to be the superpower as far as AI is concerned, and probably. That is the basic bone of contention between the two superpowers. Now, is AI going to start a new Cold War? What is your take on this? And then, what are the chances of AI, general AI, becoming a mass product? If that happens, is that going to be a very, is it worthwhile? Because it is going to be a really disruptive technology. And shouldn't we draw a line here somewhere? And for some, AI is going to, it is for sure that AI is going to have a great impact on future socioeconomic development. But then lots and lots of people are going to lose jobs. So what is going to happen to them?
Absolutely.
Can you give an answer? What's your, in fact, take on this?
No, and I think that this is a concern that a lot of people have. So you're expressing it very nicely here and concisely. So number one, but the good thing is the first question you said, is this going to be a new Cold War because of AI? I don't think it will be because of AI. I think whoever has better AI is going to win. So AI is going to be the technology differentiator in a way. And if, but rather than, it's not a fight for the resources. The good thing is you can actually develop these resources separately and in a distributed manner. So it's not oil. If one has it, the other will not. The good thing is you can actually start, every country can have their own AI programs and start developing them. But the ones who have better programs are going to be have an edge here. The second thing you mentioned about if general intelligence comes in, there's going to be a downside. And that's, you probably have heard a concern from Elon Musk as well, that it's going to be scary. And, the good thing is as humans, we've had a lot of technologies we've been scared of in the past, but once they've come in, we've already mastered them and kind of figured out ways to deal with it. So I'm less scared of what happens, but I think we want to be part of the creation of that, so that we can actually do it in a way that is more morally aligned. It's based on what we believe in, rather than any us not being part of it. It's going to happen if we put our heads under the sand and say, let's not, this is a little like troublesome. I think there is no question about it that this is not going to happen. Now the question is, do we be a part of it, or do we let it just happen itself? So I think it's going to happen, and jobs will be lost. But here, can we create other jobs, and can we train our workforces to be part of this creation of this, rather than be disrupted by it. And I think that's, if we actually are proactive about it, I think we can do something. If we are reactive and wait for this change to happen, I think we'll be sorry at the end. So I think, I'll end with this. I've gone 3 minutes over. What I'll end with is, we do have a lot of potential here of the technology, and there's no way that this is not going to happen. Now, the question is, can we be part of it? Can we use it to solve our problems? And can we have an edge and a focus on it at local level, at national level, to make sure that we are being part of this solution rather than being disrupted by the solution itself. So, but thank you so much, everyone, for taking out the time. If you have any more questions, you can contact me at my first name, Wardah, at overjet.ai, and would love to help answer those. But thank you, everyone, for taking out the time.
Thank you, Wardah. Thanks a lot. Really appreciate your time.
Thank you.
So kind of you. So kind of you for sparing this time. So Nasir, do you want to say something?
Thank you, everyone.
So Nasir, or mute.
Thank you very much, Wardah. I think you've highlighted a very important discussion. And definitely, as I told you, that we have one center for AI for the whole Pakistan, and it's fortunately positioned at NUST. And we'd like to collaborate with you. And I'll connect the faculty with you, definitely. We'll have more discussions.
Perfect. Thank you, everyone.
Wardah, I am extremely thankful to you, and I heard your father is also on this session, and I am extremely thankful to him also that I coordinated with him since long, and we get the time. And thank you for thought-provoking discussion, and inshallah we may contact you whenever there is any need.
Perfect. Thank you so much. Thank you for having me, and thank you for everyone listening to this. I hope you have a great day.
Thank you, everybody.
Perfect.
Thank you, everybody, for joining.